Hi guys, welcome to the next part, Introduction to the Amines. So in this part, we generally will be discussing about the structural concepts of amines, either the IUPAC name, either the chiral concepts. So why to waste our time? Let's start with the part, Introduction to Amines. Introduction to Amines. Structure and classification of amines. So amines are classified as 1 degree, 2 degree or 3 degree amines. So that means the amines in which there are 1, 2 or 3 hydrogens of NH3 are replaced by your alkyl and aryl groups. So you can see here that CS3NH2. So in CS3NH2, and if I consider NH3, how many hydrogens are replaced? The number of hydrogens are replaced are 1, and I am replacing that 1 hydrogen and I am replacing with your CS3. So this is a 1 degree amine and its name is methylamine, and CS3NHCS3. And what are the total number of hydrogens I am replacing here? The total number of hydrogens which I am replacing here are 2. So if I am replacing 2 hydrogens, that means it is considered as a secondary amine. So it is a second degree amine, and it is a dimethylamine because there are 2 methyl groups attached. So it is a dimethylamine. And the third thing is that it's a tertiary amine. Why it's a tertiary amine? Because the number of hydrogens which are replaced by this alkyl groups are 3. So it is a tertiary amine. So you can see here the 3 hydrogens which are replaced are your methyl groups. So if there are 3 methyl groups which are replaced, it is called a tertiary amine, or it is a trimethylamine. The name of this is a trimethylamine since there are 3 methyl groups. So amines are further classified into aliphatic, aromatic and heterocyclic amines. So if I have an amine, that amine can be classified into aliphatic, aromatic and heterocyclic amines. Let's look into these amines. So what is an aliphatic amine? If someone asks you what is an aliphatic amine, so the answer should be an amine in which your nitrogen is bonded only to your alkyl groups. So this is called an aliphatic amine. So what is an alkyl group? So your CH3, C2H5, all these are the alkyl groups. So if your nitrogen is attached to such groups, it is called an aliphatic amine. Next, aromatic amine. What is an aromatic amine? Just like in an aliphatic amine, you have an alkyl group. In an aromatic amine, you have an aryl group. That means your ring structures. That means your C6H5 benzyl group. Alright. So aromatic amine is an amine in which your nitrogen is bonded to one or more aryl groups. So what is this now? If this is an aniline, so what is happening in aniline? I have nitrogen and one of the hydrogen is replaced by your phenyl group. That means it is an aryl amine. It is an aryl group. This is an aryl group, and we know that if you have an aryl group, it is called an aromatic amine. So it is a 1 degree aromatic amine. Why only 1 degree? Because there is only 1 hydrogen replaced. Next, you have N-methyl aniline. It is a 2 degree aromatic amine. Why it is still an aromatic amine? Because whenever your nitrogen is attached to at least 1 phenyl group, it is called an aromatic amine. So even though there is 1 alkyl group, it is still considered to be your aromatic amine. So it is a 2 degree. Why again 2 degree? Because I have 2 hydrogens replaced. Next, the third thing, tertiary aliphatic amine. Why this is an aliphatic amine? The first thing, according to the definition of aliphatic amine, right, the hydrogen should be replaced by your alkyl groups. So you can see here that CS3 is an alkyl group, this CS3 is an alkyl group. Even this is considered to be an alkyl group, because here, even though there is an aryl group attached to this carbon, but this carbon which is attached to nitrogen is still considered to be your alkyl group, and that's why it is an aliphatic amine. And why 3 degree? Because there are 3 hydrogens which are replaced. So heterocyclic amine. So heterocyclic amine is that amine in which nitrogen is one of the atoms of the ring. So just like you have homocyclic amine, you can have heterocyclic amine. Just like you have aliphatic and aryl amine, you can have an heterocyclic amine. And this is the amine in which nitrogen is one of the atoms in the ring. And how can be the structure? So you can see here nitrogen is part of the ring. That means you have a carbon here, carbon here, carbon here. So here nitrogen is present as one of the element in your ring. So that is why it is called as heterocyclic amine, and that's why this is pyrrolidine, which is heterocyclic aliphatic amine. Similarly the case with this, right? So this is actually piperidine. So in piperidine also what is happening is that you have one of the nitrogen as one of the atom in the given ring. So piperidine is also considered to be your heterocyclic amine. Next, pyrrole, the same thing, your nitrogen is one of an atom. Next, pyridine also is the structure where nitrogen is one of the atom present in the ring. So such structures are called heterocyclic amines. Why this is heterocyclic aliphatic amine and why this is heterocyclic aromatic amine is an interesting thing. What is happening is that in this you have no, here you can see a double bond, right? So it is again a aryl group, but here it is just direct a carbon attached, which is nothing but an alkyl group. That's the important thing you have to understand, because this whole ring, I can say, is again your aryl group. Even though you have a cyclic structure here, but this is still an alkyl group. That's why it is an aliphatic amine, this is an aromatic amine. So aliphatic amines replace the suffix C of the parent alkane by amine. That means now this is again how to name your amines. For example, you have this structure. So if you have this structure, then it is nothing but propane generally, right? You have 3 carbons, so it can be 3, you have 3 carbons, but instead of the carbon in the last position you have nitrogen, which is nothing but your amine group. So what you have to do is that you have to replace the suffix E by this amine. That means if it is, here it is 2-propane amine. So this is again your 2-propanamine. Similarly here also what is happening is that you have a phenyl group and you have 1 phenyl ethylamine. Here also 1,6 hexane diamine. So because you have 2 amines here. So the IUPAC system retains the name aniline. You have this structure, the IUPAC system, right? According to the IUPAC system also, this is actually considered to be your aniline. So here now what is happening? You have a nitro group attached at ortho. This is ortho, this is meta, and this is para position. So you have a nitro group attached at the para position. So this is considered to be 4-nitroaniline. And here instead of nitro group you have your methyl group. So it is 4-methylanilin. Here you have a methoxy group. So it is 3-methoxy, right? Because this is the first position, this is the second position, this is the third position. But in all of these also the same thing was happening. This is the first position, second position, third position and fourth position. So it is 4-methyl-aniline. So among the various functional group discussed in the text, NH2 is one of the lowest in the order of precedence. Yes, that means now you have two functional groups here, and if you have two functional groups here, the important thing which you have to understand is that your NH2 is one of the lowest preference. That means your numbering actually starts from here and here. So it is the low, since it is the lowest preference, it is actually considered as a substituent. That means it will be the 2-amino ethanol. Because why it is ethanol? Because your alcoholic group is given the first preference. The same thing with this structure. So the numbering actually starts from here 1, 2, 3, 4. So that's why it is 2-amino 3-methyl butanol, because there are 4 carbons and you have alcohol, that's why you have butanol. So here also the same thing, 1, 2, 3, 4. So the fourth position you have so it is 4-amino benzoic acid. So this is again some of the important concept related to your nomenclature of your amines. Let's discuss further more. So the common name of the most aliphatic amines are derived by listing the alkyl groups bonding to nitrogen in one word ending with suffix amine. So you have methylamine, you have tertiary butylamine, you have dicyclopentylamine and triethylamine. So you have a name. If you don't have any substituent, obviously this will be the primary, because now you don't have alcohols, right? So if you don't have alcohol, or if you don't have any other functional groups like your carboxylic acid, obviously the name of your amines will be ending with amine itself, because it is now considered the primary group. So when 4 groups are bonded to the nitrogen, the compound is named as a salt of the corresponding amine. So for example, now you have 4 groups attached to your nitrogen, just like your tetramethyl ammonium chloride. You have 4 methyl groups attached to a single nitrogen. Here also the same thing, right? All the elements surrounded by nitrogen are completely bonded with your methyl groups or your aryl groups or alkyl groups, I can say. So now what is this? This is actually the salt, right? This is actually the salt of amine, because for example you can see NH4 plus. So there are 4 hydrogens attached to this nitrogen, because it forms a salt when you get NH4 plus. So the same thing is happening when 4 groups are bonded to nitrogen. The compound is named as the salt of your corresponding amine. So tetradiesylpyridinium chloride or cetylpyridinium chloride, it's again the salt. Similarly, benzyl trimethyl ammonium hydroxide, it's again the same thing. So there are 4 groups which are bonded to nitrogen, and this compound is named as a salt of corresponding amine. Chirality of amines. Chirality is again, it's actually representing your behavior of your optical nature. So if we consider the unshared pair of electrons on nitrogen as a 4th group, then the arrangement of groups around nitrogen is approximately tetrahedral. So an amine with 3 different groups bonded to nitrogen is chiral and exists as pair of enantiomers, and in principle can be resolved. So an amine with 3 different groups, obviously that means that an amine has 3 different groups, that means it is optically active, that means it is chiral, and that's why if it is chiral, it exists as pair of enantiomers. So obviously because of its principle, it can be resolved, right? So you can see here, you have nitrogen here, nitrogen surrounded by 3 different groups here, and you have a lone pair here. So this is actually the sp3 hybrid orbitals. So this is ethylamine, and this is ethyl methylamine, because you have ethyl group here, methyl group here, and you have obviously this actually shows the chirality of amines, because 3 different groups, and also the 4th one is your lone pair. So because of this, amines exist, amine shows a chirality. So this is a S-ethyl methylamine, and this is R-ethyl methylamine. So this is what? This is actually the unshared electron pair in the 4th sp3 hybrid orbital. So this is actually the sp3 hybrid orbital. So in practice, however, they cannot be resolved because they undergo, this is a very important process. So what happens in practice is that the amines cannot be resolved because they undergo pyramidal inversion. That means it converts one enantiomer to the other. So because of that, it cannot be resolved in practical. So you can see here, there is S enantiomer and the same structure which I just shown. So you have R enantiomer. What happens is that there is a transition state. There is a transition state and which has plane of symmetry, and because of this it is achiral. So the chirality of amines is affected because of this pyramidal inversion. What is pyramidal inversion? Is this. When there is a transition state, you have a plane of symmetry. When you have a plane of symmetry, it actually is achiral. So this is all about the different concepts related to the normal introduction of amines.
So guys, so in this part we have discussed about if you have a given amine, what is the primary amine, what is the secondary amine, what is the tertiary amine, right? So we also understood what are the differences between these different types of amines, right? So in our next part we will be discussing about one of the important concept, which is nothing but preparation techniques of amines. If you have amines, how you will generally prepare them, right? So we'll meet in the next session. Till then, just stay tuned to our parts, right? Stay tuned to our next part, which will be coming soon. So take care. Goodbye.